All right, today we're on page 46 in the book, and we're going to be talking about and defining some different angle relationships. And the first term we need to look at is called adjacent angles. And adjacent angles are next to each other. They share a vertex and a side. Adjacent angles. They're next to each other. So if we were to draw adjacent angles, if I label this angle 1 and this angle 2, well, angles 1 and 2 are adjacent to each other. If I put some points on here, A, B, C, and D, you can see that angle ABC has a vertex of point B and a side of BC. Agreed? And then angle CBD has a vertex of B and a side of BC. So ABC and CBD are adjacent. And we'll say adjacent angles. And there's multiple, or I'm sorry, there's not multiple other examples. There's a few more examples in the book if you want to look at them in the middle of page 46 under the key concept. All right. Now, if we put a point here, B, or it doesn't, point's name doesn't really matter. All right, again, if I label this angle 1 and this angle 2, angle 1 is adjacent to angle 2. They both share this vertex right here in the middle, the red point, and they both share this side, this red side. All right. So adjacent angles, they share a vertex and they share a side. We've got a linear pair of angles. A linear pair form a straight line. And are adjacent. So a linear pair of angles. We talked about this last week. If we take a horizontal line and put a point on it, and then draw a ray coming out of that point, we just created a linear pair of angles. Angle 1 on the left and angle 2 on the right are a linear pair. They form a line. Those two angles form line BC. All right. A linear pair form a straight line and are adjacent. Their sum is 180 degrees. Could form a linear pair with a vertical line. Put a point on it. Take a ray out of that point. Angle 1 and angle 2 are a linear pair. They form a straight line. A diagonal line with a point on it and a ray coming out of that point. Angle 1 and angle 2 are a linear pair. Basically, two angles, when they're next to each other and they form a straight line, their non-common side forms a straight line. They're a linear pair. They're sum 180. Vertical angles. Are formed by the intersection of two lines and they are congruent. Vertical angles are formed by the intersection of two lines and they are congruent. So if we draw two lines on your paper and just have them intersect, whenever we intersect two lines, we create four angles. We got angle 1, 2, 3, and 4. Angle 1 and angle 3 are vertical angles. And we're not using the term vertical angles as much as up and down. Vertical angles are just always across from each other. All right, so we can say across from each other. One and 3 in this picture. Angle 1 is congruent to angle 3. And there's another pair of vertical angles in that picture. Angle 2 and angle 4 are also vertical angles. Angle 2 right here is congruent to angle 4. All right, let's look at the middle of 47, page 47. Complementary angles. Complementary angles are two angles with measures that sum 90 degrees. Complementary angles sum 90 degrees. Their measures sum 90 degrees. So the easiest way to draw a diagram is to draw a 90-degree angle. And this angle's not 90 degrees until we put the little box in the corner, or the half of a box in the corner. Now, angle ABC is a 90-degree angle. Well, if we put our pencil on point B and we draw a ray up and to the right, wherever we want, we have ray BD. Well, we just formed, now we have three angles. We have the original angle ABC, we have angle ABD, and we have angle DBC. In this case, the two angles are adjacent, and they sum 90 degrees. If this angle is 60 degrees, then what's the measure of the other angle? 30 degrees. Now that's a picture of adjacent angles that are complementary. You can also just have two angles. You can have angle D right here, and let's call it 40 degrees. And then you could have another angle next to it, not touching it, not a part of it. Angle E. And if it measures 50 degrees, then angle D and angle E are complementary. All right, so complementary angles, they sum 90 degrees. They can be adjacent or they can be non-adjacent. Below that term, supplementary angles. Are two angles with measures that sum 180 degrees. Supplementary angles can be adjacent or non-adjacent. So again, if we're looking for two angles that sum 180, if we draw a straight line, put a point on it, put a ray coming out of that point, we just created angle 1 and angle 2. We know that a straight line is a 180-degree angle. So we just created a pair of supplementary angles. They're also a linear pair, aren't they? So a linear pair, they sum 180, but they need to be adjacent, next to each other, sharing a side and a vertex. So in this case, angle 1 and 2 are supplementary and they are linear. If we were to draw a angle down here, angle A, that's 120 degrees. And then next to it, angle B, that's 60 degrees. In this case, angle A and B are supplementary, aren't they? They sum 180. But they're not a linear pair because they're not adjacent and they're not adjacent to each other. They don't share a vertex and they don't share a side. So in this case, A and B are just supplementary. In the first drawing on the left, angle 1 and angle 2 were supplementary and they were a linear pair. All right, so turn the page. Let's look at the bottom of page 48. And we are going to say that segments or rays that form right angles are perpendicular. Segments or rays that form right angles are perpendicular. So if we have line L, and then we take line M and we draw it and we intersect it with line L and we try to intersect it at 90 degrees. Here's line M. If that 90-degree symbol is at the intersection of those two lines, then line L is referred to as perpendicular to line M. Now, here's the symbol for perpendicular. We say L it's an upside down T. Line L is perpendicular to line M. We read this is perpendicular to. We can call it forms a 90-degree angle. So now this symbol kind of just added another meaning to itself. That half of a red box, it means that the two rays form a 90-degree angle, or in this case, the two lines form a 90-degree angle. It means that the lines are perpendicular to each other. All right. And when we use the term right angles, they always sum 90. Or a right angle is a 90-degree angle. Now, based on what we talked about earlier, You know, we've got 4 angles in this picture. If angle 2 is 90 degrees, then what's the measure of angle 4? 90 degrees. What's the relationship between angle 2 and angle 4? Very good. They're vertical angles. Now, angle 1 and angle 2. If angle 2 is 90 degrees, what's the measure of angle 1? It's 90 degrees as well, isn't it? What's the relationship between angle 1 and angle 2? They're a linear pair of angles, aren't they? Angle 1 and angle 2 form line L, don't they? What else are angle 1 and angle 2? They're supplementary, very good. One more relationship that they have. They're adjacent to each other, very good. So in this case, angle 1 and angle 2, they're adjacent. They're next to each other. They share a vertex. They share a side. They're a linear pair because they form line L. They're supplementary. Okay. And in this case, they're congruent. And then angle 1, or if angle 4 measures 90, what's the measure of angle 3? Yeah, 90 for a bunch of different reasons, right? Angle 3 is congruent to angle 1. They're vertical angles. Angle 3 and angle 4 have all the same relationships as angle 1 and angle 2. They're supplementary, they're a linear pair, they're adjacent. All those things are true. Okay. All right, so let's look at the example up on the top of page 49, and then I'm going to give you a little bit of practice to do on your own. Top of page 49, they got a diagram up there. And we've got a couple of intersecting lines or intersecting segments. PTR, point Q, point S. Got a ray coming out of T down here. Got an angle that measures 2x degrees and an angle that measures 5x plus 6 degrees. And a 4y minus 2. And the directions asked to find x and y. So that PR is perpendicular to SQ. So PR is here, SQ is here. We want them to intersect at 90 degrees. Find x and y so that PR is perpendicular to SQ. We want this to happen. We want this angle to be 90 degrees, because if that angle is 90 degrees, then the 4 angles in this intersection are 90 degrees. So let's start with the y. What does the 4y minus 2 have to equal? For the 2 segments or lines to be perpendicular, doesn't that angle need to measure 90 degrees? So our 4y minus 2 has to equal 90 degrees. So we add 2 to each side. And our 4y equals 80. No, it doesn't. It equals 92. And divide by 4. 92 divided by 4. 23. All right, so there's our y. When our y is 23, then this angle up here is 90 degrees. And don't we want these two small angles in here combined to form a 90-degree angle? So we want our 2x plus 5x plus 6 to equal 90 degrees as well. So 7x plus 6 has to equal 90 degrees. Now we're going to subtract 6 from each side. Our 7x is going to equal 84. And we're going to divide by 7. And our x equals 12. So that's how we solve for variables so that two lines or segments are perpendicular to each other. All right, so your practice for today is going to be on page 51. And do problems 8 through 24, please. Page 51, problems 8 through 24.